All right, welcome to The Explainer. Today, we are diving into one of the absolute biggest challenges in science, the quest to build a working simulation of the human brain. And this isn't just about computers, not really. It's about understanding the very nature of who we are. For decades, a question like this was pure science fiction, right? But now, a massive, massive leap in computing power, combined with some really brilliant breakthroughs, is starting to turn that fiction into a potential reality. So, let's get into it. Let's look at exactly how scientists are architecting this digital mind and what its creation could mean for all of us. Okay, first things first. What is the grand ambition here? What are researchers actually trying to build? Well, the main goal is to finally bring together decades of pretty isolated brain research. You can think of it like this. For years, scientists have had all these separate puzzle pieces about how different parts of the brain work, and now they want to fit them all together into one single massive simulation. So, the first target? A model with 20 billion neurons. Just try to wrap your head around that number for a second. But, believe it or not, that's not even the most mind-boggling part. Because on top of that, the model needs to simulate 100 trillion synaptic connections. That number is just astronomical. And it has to be, because it's designed to match the scale of our own cerebral cortex. The part of our brain that handles all the big stuff. Language, memory, consciousness itself. Okay, so to even attempt a simulation on this scale, you need a totally new class of machine. We're not talking about your desktop or even a server farm. This is way beyond what we normally think of as a supercomputer. And that's where something called exascale computing comes in. You can basically think of it as the first non-negotiable ingredient, the sheer raw horsepower you need to even dream of simulating billions of neurons firing at once. And let me tell you, machines like this are unbelievably rare. As of today, there are only just four, publicly ranked exascale computers in the entire world. And one of them, Europe's very first, is called Jupiter. It's based at the Jülich Research Center in Germany, and that is exactly where researchers are getting ready to run these absolutely groundbreaking brain simulations. But here's the thing, just having a powerful engine, it's not enough. The team ran into a huge hurdle, and it wasn't what you'd expect. The problem wasn't running the simulation, it was just building it in the first place. And to solve that, they needed a completely new, brilliant blueprint. See, the old way of building this digital brain network was just painfully slow. It created this massive data traffic jam. Imagine one central computer trying to organize the entire network, and only then, finally, sending out instructions to the thousands of powerful chips that were supposed to be doing the actual work. It was a huge bottleneck. So this new onboard method, it flips that whole process on its head. The library analogy here is just perfect. Instead of having one central librarian trying to catalog every single book in the entire building, you just let each room or each section organize its own books, all at the same time. It's just a way smarter parallel approach. And the results? It's a total game changer. The setup time plummets from 12 minutes all the way down to just 55 seconds. We're talking more than a 10-fold speed up. This one innovation basically turned a crippling bottleneck into a superhighway for brain research. It's huge. Okay, so the tech is there. We can build these models bigger and faster than ever before. But so what? Why is that scale so important? Why not just stick with smaller, more manageable simulations? Well, to put it in perspective, scientists just recently finished mapping the entire brain of a fruit fly, which, by the way, was a massive achievement. But the leap from a fruit fly's brain to a human's, it's almost impossible to comprehend. We're not just adding a few more neurons here. We're going from about 100,000 neurons to 86 billion, and from millions of connections to over 100 trillion. The scale is it's a different universe. And as lead researcher Marcus Deisman explains, this isn't just about getting more of the same data. He says large networks can do things that are qualitatively different from small ones. It's kind of like what we see with AI, right? Simply scaling up a model doesn't just make it a little better at what it already does. It can unlock entirely new abilities that just didn't exist before. Okay, so where does all this leave us? In this final section, let's unpack the incredible promise of this work and what is honestly a pretty big paradox. The potential here is enormous. These full-scale simulations could become these invaluable digital laboratories. I mean, they let us ask questions that are just impossible to test on a living person. Imagine watching a memory actually form in real time, or seeing the precise effect of a new drug for epilepsy as it works its way across the entire brain. That's the kind of thing we're talking about. But, and this is a big but, this leads us to the central paradox of the whole project. And collaborator Thomas Nowotny just nails it with this quote. He makes this really crucial distinction. They can make simulations the size of a brain, but that is not the same thing as making a simulation of the brain. And that's the key takeaway here. These amazing, mind-bending simulations, they're still missing some really essential components. They don't account for that complex soup of hormones and chemicals that are always washing through our brains. They don't capture the brain's incredible ability to physically rewire itself, what we call plasticity. They don't have input from a real body living in a real world. And of course, the deepest mystery of them all, consciousness itself, that's still way, way beyond their scope. So let's be clear. The goal here is not to build a conscious mind in a box. It's to build the most powerful digital mirror humanity has ever created, a mirror to help us understand ourselves. And that leaves us with one final fascinating question. When we look into this new digital mirror, what secrets, hidden deep inside our own minds, will it finally reveal?